Hello, dear students. Welcome to the another episode of group number 15. It's a nitrogen family study of P block elements chapter. The elements present in the nitrogen family are nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. We are studying one important compound of nitrogen, that's a nitric acid. In the previous class, we studied very important concept as far as your theory examination is concerned. That's a manufacture of nitric acid by Ostwald's process. Okay, so can you see the three steps, three equations? These equations are very important. These equations we have studied in the previous class. These are of a manufacture of nitric acid by Ostwald's process. Okay, so let us begin our today's class. We'll continue with the study of nitric acid. Today we'll see physical property, very few physical properties, some chemical properties important for competitive examination is concerned, and few uses of nitric acid. Fine? Okay. Nitric acid is a colorless liquid with a melting point of 231.4 Kelvin and a boiling point of 355 Kelvin. This nitric acid is a laboratory grade. Whatever the nitric acid present in our laboratory, we use in our laboratory, it's not of 100% strength. It's almost 68% nitric acid by mass. In the gaseous state, if you look at the structure, the nitric acid has a planar structure. Structure ಬಗ್ಗೆ ಹೇಳೋದಾದ್ರೆ nitric acid is a planar molecule. Okay, so today we'll discuss very important chemical properties, chemical reactions of nitric acid. I'll repeat, these are important both for your theory examination, but they are more important for competitive examinations are concerned. Okay, chemical properties of nitric acid. Okay, nitric acid is acidic in nature. It's areneous acid because when this nitric acid is dissolved in water, in aqueous media, in aqueous solution, the nitric acid HNO3 dissociates into NO3 minus and H plus. That H plus combines with a H2O forming H3O plus hydronium ion. So this ionization of nitric acid in the aqueous solution indicates that nitric acid is a strong mineral acid. It's a areneous acid because in aqueous solution it gives what? Hydronium ion and a nitrate ion. It dissociates into H plus forming hydronium ion with water. Second chemical property, very important property, oxidizing property. Concentrated nitric acid, even dilute nitric acid also. The concentrated nitric acid is a strong, very good, powerful oxidizing agent, and it attacks most of the metals, almost all metals except noble metals such as gold and platinum. Okay, except gold, platinum, and very few aluminum and chromium that we'll see later. So this nitric acid oxidizes almost all metals. Therefore, we call it as a very strong, good oxidizing agent. And when a nitric acid is used as an oxidizing agent, the products of oxidation depends upon the concentration. The product of the oxidation process depends upon what? Concentration of the acid. So if the acid is strong, concentrated, we'll get one kind of a product. If the acid is dilute, we'll get another kind of a product. Andre, the concentration will decide the formation of product. The temperature will decide the formation of product, as well as the nature of the material undergoing oxidation. That also decides the oxidation product. Okay, so ಏನು ಹೇಳ್ಬೋದು ಹಾಗಾದ್ರೆ, the product of formation of a product when a nitric acid is used as an oxidizing agent, that depends upon concentration of acid, that depends upon temperature, and that depends upon the nature of material undergoing oxidation. Okay, so now we'll see some of the chemical reactions in which nitric acid behave like a oxidizing agent. First, we'll see metals. Nitric acid react with the most of the metals. I said no. We'll see example. Copper metal. When a copper is treated with a dilute nitric acid, okay, look here. So we are studying the reaction of a copper metal with concentrated nitric acid as well as reaction of a copper metal with dilute nitric acid. Both we'll see. So when it is reacted with a dilute nitric acid, copper undergo oxidation into copper nitrate. 3Cu plus 8HNO3 gives 3CuNO3 twice copper nitrate, along with the formation of water as a byproduct, and one more byproduct is 2NO, nitric oxide. Okay, when a copper undergo oxidation in the presence of dilute nitric acid, it oxidizes into, copper oxidizes into copper nitrate, and nitric acid itself gets reduced into nitric oxide. This is the reaction of a copper metal with a dilute nitric acid. Ade, if you take a concentrated nitric acid and treat with a copper on treatment with 4HNO3, concentrated HNO3, it forms again copper undergo oxidation into copper nitrate, Cu plus 4HNO3 plus CuNO3 twice, along with the formation of a byproduct water, 2H2O plus, look at the another byproduct. It forms oxide of nitrogen, which is NO2, 2NO2, nitrogen dioxide. Okay, so nodi, the product of the product formation here, in the first case we are getting a nitric oxide, in the second reaction we are getting nitrogen dioxide. Andre, the product formation depends upon the what? Concentration of a nitric acid. Okay, so if you react with a dilute HNO3, there is the formation of a nitric oxide. Whereas if you react copper with a concentrated nitric acid, there is a formation of what? Nitrogen dioxide. So this is the difference here. Nitric oxide in first reaction, nitrogen dioxide in a second reaction when copper treated with concentrated acid. Clear? We'll take another example of a metal reaction with a nitric acid. Zinc metal, 4Zn plus 10HNO3. Here nitric acid is dilute. When a zinc metal reacted with a dilute nitric acid, there is a formation of a zinc nitrate. Zinc undergo oxidation into zinc nitrate, along with the formation of byproduct water. 4Zn plus 10HNO3 gives 4ZnNO3 twice plus 5H2O, along with the formation of N2O. Again, oxide of a nitrogen, it is N2O. We call it as nitrous oxide, commonly called as laughing gas. N2O, nitrous oxide is laughing gas. Hagadre, conclusion when a zinc metal reacted with what kind of acid? Dilute nitric acid, there is a formation of a nitrous oxide, N2O, along with the formation of what? Zinc nitrate. We'll see reaction of a zinc with concentrated nitric acid now. Sorry. Zinc on treatment with concentrated nitric acid, Zn plus 4HNO3, it gives zinc nitrate, ZnNO3 twice, plus water as a byproduct, 2H2O plus. There is a formation of a oxide of a nitrogen, that is 2NO2, nitrogen dioxide. Again, what's our conclusion? When a zinc react with a dilute nitric acid, there is a formation of zinc nitrate and nitrous oxide. Whereas, if a zinc react with a concentrated nitric acid, there is a formation of zinc nitrate and nitrogen dioxide. Hagadre, ಏನು ಹೇಳ್ಬೋದು? The product formation will depend upon the concentration of acid. I'll repeat, these reactions are important for 1 mark. Any one reaction is important for your board examinations are concerned. But competitive examinations ge ella reactions bhala important. Clear? Work out on these reactions. Very simple reaction. Copper into copper nitrate, zinc into zinc nitrate. There is a byproduct formation of water. So you need to remember here what? Which oxide is formed in the when copper with a dilute nitric acid, nitric oxide. Copper with a concentrated nitric acid, nitrogen dioxide. Zinc with a dilute nitric acid, nitrous oxide, and zinc with a concentrated nitric acid, nitrogen dioxide. So this formation of oxide of nitrogen is very important. Adan bitre reactions are very simple. Work out on these reactions, practice on these reactions. Clear? So this is reaction of metals, for example copper and zinc, with a dilute and concentrated nitric acid. Fine. Concentrated nitric acid not only react with metals, it also react with non-metals. Concentrated nitric acid also oxidizes non-metals and their compounds. We'll see some examples. Concentrated nitric acid oxidizes carbon into carbon dioxide. Carbon is a non-metal. Non-metal ಜೊತೆನೂ ರಿಯಾಕ್ಷನ್ ಆಗ್ತದೆ. ಅದು ಆಕ್ಸಿಡೇಷನ್ ಮಾಡ್ತದೆ. ಕಾರ್ಬನ್ ಇದ್ದಿದ್ದನ್ನ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಮಾಡ್ತದೆ. Reaction is like this. Carbon C plus 4HNO3 nitric acid. Here we are taking the only concentrated nitric acid for the reaction of non-metal, because these are mentioned in your textbook. Okay, reaction of a dilute acid with the non-metals is not mentioned. Don't worry about that. Carbon, when reacted with a concentrated nitric acid, carbon undergo oxidation into carbon dioxide along with the formation of a byproduct water to H2O plus in form ಆಗಬಹುದು ಎಸ್ ನೈಟ್ರೋಜನ್ ಡೈಆಕ್ಸೈಡ್ 4NO2. Equation ನೋಡೋದಾದ್ರೆ C plus 4HNO3 gives CO2 plus 2H2O plus 4NO2. So carbon undergoes oxidation for carbon dioxide. Nitric acid. So here carbon undergo oxidation to carbon dioxide. Nitric acid, being a oxidizing agent, itself undergo reduction into nitrogen dioxide. It's a first reaction of a non-metal carbon with nitric acid. Okay, these all are oxidation reactions, redox reactions, wherein the non-metals undergo oxidation. Second one, iodine is oxidized into acid. Which acid? Iodic acid. Equation I2, iodine on treatment with a 10HNO3 concentrated nitric acid, there is a formation of 2HiO3. HiO3 is iodic acid. Iodic acid. Here iodine in the presence of concentrated nitric acid undergo oxidation to form iodic acid along with the formation of byproduct 4H2O, and same oxides of nitrogen is formed here. NO2, 10NO2, nitrogen dioxide. Okay, so I2 plus 10HNO3 gives 2HiO3 plus 4H2O plus 10NO2. Iodine undergo oxidation into iodic acid. Concentrated nitric acid undergo reduction into nitrogen dioxide. The third one, the non-metal phosphorus, when on a treatment with a concentrated nitric acid, undergo oxidation into phosphoric acid. P4 is a phosphorus, molecule of a phosphorus. On treatment with a concentrated nitric acid 20HNO3, it gives 4H3PO4. H3PO4 is phosphoric acid. Byproduct is water, 4H2O, along with the formation of nitrogen dioxide, 20NO2. Equation ನೋಡೋದಾದ್ರೆ P4 plus 20HNO3 gives 4H3PO4 plus 4H2O plus 20NO2. Another non-metal, sulfur, on treatment with a nitric acid undergo oxidation into sulfuric acid. Equation S8, sulfur on treatment with a concentrated nitric acid 48HNO3, there is a oxidation of a sulfur into sulfuric acid, 8H2SO4 plus byproduct water, 16H2O, along with the formation of again nitrogen dioxide, 48NO2, nitrogen dioxide. Okay, so these four reactions now, in Paivo, reaction of non-metals carbon, iodine, phosphorus and sulfur with a concentrated nitric acid. Okay, so reaction ನೋಡೋದಾದ್ರೆ ದೊಡ್ಡ reaction ಅನ್ನಿಸ್ತದೆ. S8 plus 48HNO3 gives 8H2SO4, 16H2O, 48NO2. Okay, the reaction is quite very simple. ಸೊ ನೀವು ಸ್ವಲ್ಪ ಇನ್ನು ಎಲ್ಲ 4 ರಿಯಾಕ್ಷನ್ಸ್ನ ನೋಡ್ರಿ, ಏನಿದೆ ಭಾಳ ಸಿಂಪಲ್ ಇದೆ. ಕಾರ್ಬನ್ ಟು ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್, iodine to iodic acid, phosphorus to phosphoric acid, sulfur to sulfuric acid. Next, HNO3 ಏನಾಗ್ತದೆ NO2, 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 NO2. It gets reduced into nitrogen dioxide in all the case. Mattin the product ಏನು byproduct will be water. So if you take one carbon ತಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗ್ತದೆ 1 ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್, ಇಲ್ಲಿ I2 ಎರಡು ಅಯೋಡಿನ್ ಇದಾವೆ 2 HiO3 ಮಾಡ್ರಿ. ಇಲ್ಲಿ P4 4 ಫಾಸ್ಫರಸ್ ಅಟಮ್ ಇದಾವೆ ಮಾಲಿಕ್ಯೂಲ್ದಲ್ಲಿ 4 H3PO4 ಆಗ್ತದೆ. ಇಲ್ಲಿ S8 is a sulfur molecule, 8 atoms are there. ಇಲ್ಲಿ S8 ಇರೋದ್ರಿಂದ ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲಿ ಏನಾಗ್ತದೆ 8 H2SO4 ಆಗ್ತದೆ. ಓಕೆ, ಇದು ಟ್ರಿಕ್ ಸಿಂಪಲ್ ಇದೆ. ನೆಕ್ಸ್ಟ್ NO2 ನೋಡ್ರಿ, 4 HNO3 ತಗೊಂಡ್ರೆ 4 NO2, 10 HNO3 ತಗೊಂಡ್ರೆ 10 NO2, 20 HNO3 ತಗೊಂಡಾಗ 20 NO2 and 48 HNO3 ತಗೊಂಡಾಗ 48 NO2. Okay, if you remember, if you follow these tricks, these all reactions are very simple. Work out on these reactions, practice these reactions, very important for CET, NEET, JEE examinations. Fine? Okay. Okay, one very small concept. Passivity of aluminum and chromium with concentrated nitric acid. In Pytho, I said most of the metal except the noble metals react with the concentrated nitric acid. I said, you know, we took 2 examples of copper and zinc, but there are 2 metals, example chromium and aluminium. These metals do not dissolve in concentrated nitric acid. Okay, they do not dissolve in nitric acid. Why? Because there is a formation of a passive film, passive layer of oxide on its surface. In pi concept andre, when you react concentrated nitric acid with either chromium or aluminium, okay, aluminium metal na treat ಮಾಡಿದಾಗ the atoms present on the surface of that aluminium metal, no, they undergo oxidation. They undergo oxidation and form a kind of a film, a layer of oxide on its surface. A metal ಸುತ್ತಲೂ ಏನು ಫಾರ್ಮ್ ಆಗ್ತದೆ, ಆಕ್ಸೈಡ್ ಲೇಯರ್ ಫಾರ್ಮ್ ಆಗ್ತದೆ. ಓಕೆ, ದಟ್ ಆಕ್ಸೈಡ್ ಲೇಯರ್ ವಿಲ್ ಪ್ರಿವೆಂಟ್ ದ ಫರ್ದರ್ ಆಕ್ಸಿಡೇಷನ್ ಆಫ್ ಅಲ್ಯೂಮಿನಿಯಂ ವಿತ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್. ಓಕೆ, ಅಲ್ಯೂಮಿನಿಯಮ್ದು ಮೇಲ್ಗಡೆ ಆಕ್ಸಿಡೇಷನ್ ಆಗಿ ಒಂದು ಲೇಯರ್ ಫಾರ್ಮ್ ಆಗಿಬಿಡ್ತದೆ. ಉದಿದ ಅಲ್ಯೂಮಿನಿಯಂ ಒಳಗಿರೋ ಅಟಮ್ಸ್ ರಿಯಾಕ್ಷನ್ ಆಗೋದಿಲ್ಲ. The formation of an oxide layer, oxide film, act as a passive film, andre non-reactive ಮಾಡ್ತದೆ ಅದು. Therefore, the aluminum or even chromium will not dissolve in concentrated nitric acid because of the formation of an oxide film, oxide layer, passive oxide layer on the surface of their metals. Therefore, further oxidation does not take place. Hence, this concept is called passivity with aluminum and chromium of nitric acid. Okay, very important, very beautiful brown ring test in PUC second year. In a practical class, salt analysis ali you are performing this very beautiful brown ring test. I'll just give you some here, what you call a brief test about this brown ring. Okay, heng form ಮಾಡ್ತದೆ, ಏನಾಗ್ತದೆ chemical reaction ನೋಡೋಣ. Actually, this test, brown ring test, is a qualitative test, confirmatory test, CT, for the presence of nitrate ion, NO3 minus. Salt ali ಕೊಟ್ಟಿರೋ inorganic salt ali NO3 minus radical, negative radical, acid radical is present or not, ಅದನ್ನ ಕನ್ಫರ್ಮ್ ಟೆಸ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ಈ ಬ್ರೌನ್ ರಿಂಗ್ ಟೆಸ್ಟ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಐ ಎಕ್ಸ್ಪ್ಲೇನ್ ಯು ಫಸ್ಟ್ ವಾಟ್ ಈಸ್ ದಿಸ್ ಟೆಸ್ಟ್, ಅದನ್ನ ಹೇಳ್ತೇನೆ. Don't worry, you are performing the same test in your laboratory when you come back to the college. So in one test tube you need to take the solution, original solution containing a nitrate ion present ಇದ್ದಾಗ. Okay, so ಅದರ ion ನ ತಗೋಬೇಕು. Here they have taken nitric acid ಅಂತ ತಗೊಂಡು, because nitric acid also contain NO3 minus, no? Okay, so NO3 minus ಇದ್ದಿದ್ದು solution ತಗೋಬೇಕು. To that 2 to 3 drops of concentrated sulfuric acid is added to that solution. Okay, so we need to cool this test tube under tap water. Cool ಮಾಡಬೇಕು. After that, a freshly prepared ferrous sulfate solution. So can you see this test tube contain what? Ferrous sulfate. ಈ test tube ಅಲ್ಲಿ ಏನಿದೆ, our salt solution is there plus concentrated sulfuric acid is there. We have cooled the test tube. To that test tube, freshly prepared FeSO4 is added slowly along the wall of the test tube. So ಈ ವಾಲ್ ಆಫ್ ದಿಸ್ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ ಸ್ಲೋ ಆಗಿ ಫೆರಸ್ ಸಲ್ಫೇಟ್ ಆ್ಯಡ್ ಮಾಡಬೇಕು. ಆ್ಯಂಡ್ ಯು ಶುಡ್ ನಾಟ್ shake the test tube. After few moments, after say 1 minute, 30 seconds to 1 minute, there will be formation of a brown colored ring at the junction of two layers in the test tube. Very beautiful ring you will get. So this will be like this. Ee riti kanastade. Can you see this picture? Okay, so between the junction of two layers there will be formation of a brown colored ring. ಈ ಟೆಸ್ಟ್ಗೆ ಏನಂತಾರೆ, ಬ್ರೌನ್ ರಿಂಗ್ ಟೆಸ್ಟ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ವಿಲ್ ಸಿ ಕೆಮಿಕಲ್ aspect of this brown ring test. The presence of nitrate ion in the salt, I just explained can be detected by brown ring test. The test depends upon the ability of Fe+2 ions to reduce nitrates into nitric oxide. I'll take an equation so that this sentence will be clear to you. Which react with Fe+2 forming brown colored complex. Okay, so rest sentence will be whatever I have explained the test now. Same thing is there. Look at this reaction. NO3 minus nitrate ion present in the salt solution, or if you take nitric acid that also contain in aqueous solution, NO3 minus, that on treatment with the Fe+2, 3Fe+2, Fe+2 elinda bantu ferrous sulfate. We are added ferrous sulfate that contain Fe+2 and SO4 minus 2 in the presence of 4H plus. In the presence of acidic media, we are added concentrated sulfuric acid to test tube. Okay, so here what happens, Fe+2, this Fe+2 reduces NO3 minus into NO. Fe+2 reduces nitrate into nitric oxide. So ಇಲ್ಲಿ Fe+2 act as a reducing agent, so which reduces nitrate ion into nitric oxide along with the formation of Fe+3. Fe+2 undergo oxidation into Fe+3. Okay, in a first step. In a second step, look at this reaction. The nitric oxide NO formed in the on treatment with Fe+2 in the first step, that react with this complex ion FeH2O6 times 2 plus. This is formed in the reaction media because we have added FeSO4 in aqueous media is there. This complex ion FeH2O6 times 2 plus is formed, that react with the NO nitric oxide. They are forming a complex ion, coordination complex ion FeH2O5 times NO 2 plus. So this complex is nothing but brown colored ring. Okay, it's a penta aqua H2O5 terms andre nidu penta aqua NO nitrosyl iron 2 plus, its name. Okay, you are studying these names in the coordination chemistry chapter. It's a penta aqua nitrosyl iron 2 plus, which is a brown colored ring complex. Okay, so when this brown colored ring is formed, when there is a NO groups comes. Okay, NO group elinda bantu, NO groups comes from what? Nitrate ion. Hagadre in turn what we conclude, nitrate is present in the given salt solution anta anbodu. Okay, so this is important for what you call practical examination, practical classic important, theory gain important, competitive exam gain important. These two reactions are important. Okay, reactions you remember the brown colored ring complex formula FeH2O5 times NO square bracket 2 plus. You remember this concept. Clear? Fine. Uses, last concept, uses. Nitric acid is used in the manufacture of some explosives like TNT, trinitrotoluene, as well as it's used in the manufacture of explosive dynamite. Another use, it also used in the preparation of an inorganic compound ammonium nitrate, which act as a fertilizers in a very small concentration. It's also used as an oxidizer in a rocket fuels and in the preparation of some organic compounds like a nitroglycerin organic compound and many other organic compound preparation dalli nitric acid use ಮಾಡ್ತಾರೆ. Okay, so not with this we have completed the study of nitric acid. In the previous class we discussed manufacture method of a nitric acid by Ostwald's method and few laboratory methods. Today some physical properties, very important chemical properties, and uses of nitric acid. Okay, so if you understand my video, so please subscribe to my channel. You can see, so subscribe button on the left of on the right of my name. Okay, please subscribe to my YouTube channel and share this video to your friends. Okay, so in the next class I'll be explaining a small concept of oxides of nitrogen, so that group number 15 will be completed. Later we'll move to the group number 16, that's oxygen family. Thank you very much.